Hi everyone. Last section we have seen about the seaborne visuals, right? So here we will be going and learning about the Plotly. Okay. So Plotly is again, it's a Python library, right? So it enables interactive and quality visuals. So it supports a variety of charts, different types of charts, and yes, a lot of charts are quite interactive, right? And we can actually embed in web applications and different notebooks as well. Okay, so here I'm using the Google Colab. Okay, so uh, this is how the Google Colab looks like. So either you can run in VS Studio, Jupyter Notebook, or Google Colab. Wherever it is, you can run this particular snippet of codes. Okay, yeah. So here I'm just importing the pandas. Import pandas as PD. Okay, so pd.read underscore csv. I'm initializing the path. Okay, the path which I need to give. Okay, so you need to click here on the files. Okay, so either you can actually go to this particular downloads, uh, then you can actually import the csv file like this. Okay, so this is how the steps in Colab, and click on this copy path and delete everything and control V. Okay, so this is how we need to specify the path. So click here, three dots, copy path. So this is how you need to run it like this. Okay, so once you run this, it says if I give train dot head of 20 first 20 information, right, from this data set. So here I have initialized train, whereas in my last class I have initialized Titanic underscore data. Okay, anything is fine. Okay, yeah. So train pd dot read underscore csv, this particular path, and train dot head, it gives the first five information here, and if I give the head of 20, it just give the first 20 information, right? Yeah, looks good. Yeah, so now we will actually go ahead and see what all visuals, additional visuals we can actually learn, right? So as I say, this Plotly is again a Python graphic library, right? So that's called Plotly, right? So this Plotly is nothing but interactive, and it has a lot of quality visuals ahead. Okay, so we can actually create lot of interactive in the sense the user can actually interact. So we can actually play around with that, right? So with the different colors, size, so if you want zoom in, zoom out, everything is possible here, right? So that's the power. So if I want some zoom, which zoom in, zoom out, everything, right? So consider I want to know only this particular information, something, so I can zoom in, zoom out. So everything is possible here. Okay, in Plotly. Okay, so if I hover over my mouse, it says what is what. Okay, so let me go ahead and start with Plotly. Okay, so you need to do pip install Plotly. So this is how we need to install the Plotly library. Okay, so pip install Plotly. Okay, so this is how we need to install. Okay, so after that you need to do import plotly dot express as some name px. Okay, import plotly dot express as px. So this px we will be taking in implementing further codes. Okay, px dot scatter, that is, it gives me the scatter plot. Okay, so these are different plots. Last section we have seen bar chart, count plot, histogram, then count plot, and so on. So right, so this is the, here we are actually seeing the scatter plot. Okay, so this is scatter plot, it is type of plot, so it displays the individual data point on the two dimension space. Okay, whereas each point here represents the value of the two variables. Okay, so here we will have two x-axis and y-axis. So each point represents the value of two variables, right? So here we have variables of age and variables of fare. Okay, so I'm using a scatter plot, calling the name, right? then which all columns I need, right? Then I use something called hover data. So here I use like what is the columns that I need, age column and the fair column, and what is the size. So these are some of the syntax that you need to refer. Okay, so then we have something called hover data. Okay, so this hover data is nothing but it allows the to specify what are the additional parameters that we want, like what are the additional column that we can also consider for the analysis part, and the title. So what is the title that we need for this visual, right? This is the title, right? Yeah. So we have x parameter, y parameter, what color we need, right? Depends on, and what is the size, and what is the additional feature or additional columns that we want to display. Okay, so these additional columns we will be taking in the hover labels. Okay, and the title. And next I'm updating the figure layout, x-axis title with respect to y-axis, what will be my y-axis here, and legend, like legend in the sense the names, right, associated with it. So names, and show the legend. So legend means if I hover over my mouse, it says for each point what is age, what is fair, what is P class, what is name, what is sex, and what is survived, right? So that's the power of this show legend equal to true. Okay, so it says like some of the passengers, right? That is age 35, P class 1, survived 1, and here I can see this blue color for not survived and yellow color for survived. Why? Because here I've set the color equal to survived, right? Yeah. So it is very simple, right? It's very interactive. If I want to zoom out, everything is possible, right? Yeah. So if I want to zoom only these points, that is also possible. Zoom in, zoom out, everything is possible. Okay. Yeah, so there are a lot of options here. Okay, so I can zoom in, zoom out. Okay, if I want some particular piece, so that's why we say Plotly is interactive. Okay, we can actually play around with this different visuals. So next, okay, so this is how we need to import, right? Import Plotly for graphs. Dot graph objects as go, and this go we will be using inside the figure for training all the columns. So whatever we have columns here, that is nothing but train dot columns, right? So print all the columns, right? So I mean fetch me all the values. See, it is very interactive, right? So here we have zoom in, zoom out. Once we scroll down our mouse, so it's very easy to see, like maybe I need to check row number 385 what is what, so it's very easy, right? Instead of going and checking the data set. Yeah. Okay, so that's the same code. So when you can actually use this code, okay, change this whatever name that you need to initialize for this data frame. When we are importing the pandas, then you can actually use the same code for other data set as well. Okay, yeah. So next, yes, again for some other thing for scatter plot, fair and age, color equal to survive, size equal to fair. So again what we saw just before, so when we hover over the mount, it says what is what, survived, that is 0, blue is 0, that is not survived, and yellow is survived. Okay, and if I want to zoom in, zoom out, everything is possible. Then we have something called pie plot. Okay, so I think there are a lot of plots. Okay, even you can test it out. So once you go to this Plotly Express website, so a lot of syntax available, you can play around with that. Okay, and you can actually try giving your set of columns, and definitely you can have a lot of interactive visuals, play around with that for further analysis. Okay, and for this pie plot, okay, so this pie plot is nothing but it is a what to say straightforward graph. Okay, it is useful for the displaying the proportion of each category, right? Yeah, so if I use figure equal to Plotly that px, right, px dot pie, that is pie plot, my data frame name, right? Then names, which are the columns that I need. Here I need only one column, right? then title, what title I need to bring. So it says like it displays the proportion of each category, right? Survived, that is 38.4 percentage from my data. Not survived, it is 61.6. That is not survived category is more from my data set. Okay, so using this pipe plot, what we can actually understand is we can actually display the proportion, right, for each category it belongs to. So we have something called names and we have something called title. Okay, so if you want some values, that values also we can actually add it. So just remember the syntax. Okay, what will be the syntax? So here the data frame name, then the columns. If you want addition column, yes, you can add that. Then the title. Okay, then figure dot show. Okay, next, yeah, next adding the same thing with something called radius, right? Hole. So we can actually change the radius of this particular thing. So hole equal to 0.4. So what happens? This uh, uh, particular thing reduces, increases, or whatever, right? Depends upon the parameter that we initialize here. Okay. So next we have something again. So if you want some stylish plots, right, for this pie plot. So here we use something called data, go pie, labels. So we use something called pull. Okay. So pull means if you know that particular segment or that particular category, I need to you know shown it separately, right? Separate category. So that's why I use pull. Okay, so here I am declaring labels of train and embedded column, and embedded column has 4 category including null. So that's why I need to initialize the 4 different values. Okay, so we can actually customize this. Okay, depends upon the different values, different colors. Okay, so all these are very important when you are going and building the stylish plots and all. Okay, so definitely if you want to change the angle, so which rotate the pie chart, so we can actually customize like that also. Okay, so which we, in this case it actually pulls this particular shape separately, right? That means this particular point I have given very less, so this is again very less, right? And 0 means it stays constant there itself, no change. So yeah, some kind of stylish plots we can build. Okay, yeah. So next we have something, yeah, so again we use something called subplots. Okay, so inside these subplots we have 3 different pie charts. Okay, but all the syntax are same, just now we saw, right? The inside the pie chart we can actually call which data frame, which is the column that we need, but here we can actually specify embed we want only C, embed we want only S, and embed column we want only Q, right? With respect to survive, survived, and survived, and separately show me pull, right? 0.1. So that means the separately it will show up, right? Yeah, it will actually display it separately, and title. So 3 different titles uh, with C, S, and Q, and get me the figure, right? So this is again the pie chart. So it looks very good, right? Yeah. So this kind of visuals also you can actually build. Okay, next we have something called histogram. So histogram just now we shown, right? Yeah. So I have actually explained about uh, count plot, right? So it says median value, maximum value, minimum value above the histogram. So that's what I did just now. Okay, so in my last class I've explained you all this, right? Yeah. So histogram is nothing but it says the equal distribution from my data set. So here histogram represents to age, right? Age column, and number of bins I need, and margin equal to box. So I need it in the box. So it says age group between 20 to 35 is more in my data set, right? And also this histogram, what it can say is it can actually say yes, what will be my distribution, right, of my data set looks like. So all this, we can actually find using this histogram. Okay, So, and on top of this histogram it says like what is the median value. So median value is somewhere around 30, right? And what is the minimum value? Minimum value is somewhere around 5, right? So yeah. And what is the maximum? Maximum is age 66. So age 66 is maximum from my data set, right? Yeah, so it also says the equal distribution as well. So in this histogram, this bins is very important, right? Bins says like what is the range of values that are divided to equal intervals, right? So here 30 means the 30 equal intervals are being built. So if I give interval 10, so that means the size of this graph little bit it shrinks, right? So we have x-axis and y-axis here. Okay, x-axis is age and y-axis is count. Okay, so this is about the histogram. So next we have something called histogram with hist normal. Okay, so hist normal is again it looks same only. Okay, there is nothing special here, but hist norm what that is that we are specifically saying we need the probability density value. So hist normal parameter is nothing but if we can actually specify, right, n number of bins we want, what kind of histogram we need. And so basically this is normal, right? Ist normal is nothing but histogram. It actually normalizes the value, so it provides a relative frequency distribution. So it rather than a count distribution, so it gives the relative frequency distribution. So here it says, right, yeah, what is equal frequency distribution here for age. So most of them are increasing in between 50 to 35, right? Yeah. So again this is normal has something parameters as we can have count, percent, probability, density and all those. Okay, yeah, so just for your understanding, next we will move to box plot. So I already explained you, right, box plot in the last class when explaining from the images from Google Images as well, right? So this is how it looks like. So box plot, it says like what is the maximum value, minimum value and the median value. Okay, so box plot it's actually gives the represents the interquartile range, IQR. Okay, so this line inside the box, right, it is called the median, right? And this is nothing but the maximum value and the lowest value. So age we can actually find lowest value is just hover over your mouse, it says what is what, right? Age around 0 and maximum value is age is 80 and median value is 37, right? Yeah, so this is first Q1, right? Q1, Q3 and median. So Q1 is first quartile, third quartile and the median value. So this represents the IQR. Okay, yeah, so these box plot are again useful for comparing the distributions of different groups of variables. So they provide a visual summary of the central tendency and spread of the data. Okay, so it says like what is the spread of my age. So compared to the passenger 1, most of the median value of age is 37, whereas P class 2 the middle age is 29 and median value of passenger 3 class is 24. So something like that. So some sort of analysis we can actually build. Next we will actually see on top of this how we can actually build box plot, right, with the points. So it says like point means if there are a lot of points, so here the lot of distributions of these points are more here, something like that, right? So again this sort of other analysis we can actually build. Then again this top of box plot, so we have something called notched equal to true, right? So this is how it looks like. Instead of box, like there is some shape that is associated, right? Yeah, notched. So that is only difference here. Okay, so it has some shape difference, but all the analysis is good, right? Far better from previous, right? So again this notch is added, we could say other feature, right, with respect to the median line. So this notch represents the confident interval around this median. So that's the only difference. Okay, so almost all the value implications are same. Okay, but always remember if the notches of two box plot does not overlap, So that means this suggests that medians are significantly different. So these medians will be different. So that's why there is two notches are not being overlapping each other. Okay, so this again kind of notches provide what to say complete different sort of visuals, right, when we are comparing with the medians and all. So there is no overlapping notches and all. So we can actually adjust this sort of examples to customize our preferences to different columns and all. We can actually check. Okay. Yeah, next we have something called violin plots. Okay, violin plot actually looks something like this. Okay, so violin plot is again other sort of, yeah, all these are used for analysis purpose only, but it looks something like this. So these are the parameters, right? Color, labels, orientation, violin mode, points, box, logex, title, width, and so on. Okay, so again all this again used for data visualization purpose only. So it just combines the box plot, and we have something called kernel density plot. So it just combines both plots. So again it provides some insights into the distribution of the data by showing the probability density of different values. So it says like here the more it is expanded, right, this violin shape is expanded. That means most of the data points are here in this. So the point dotted points are more here, right? So that means age in between, what is this age called 28 near to 30, right? 30 and age group 20. So 20 to 30, 38 is more here, right? Some analysis we can actually draw from all this analysis. Okay, so you can actually see some violin plots being expanded here. So that means most of the data points lie in these points. Okay, yeah, so a lot of violin points, so you can actually check with different other columns as well. So next with, yeah, same thing, we can actually check with p class, age, and survive column with top of box plot, right? So again some sort of analysis we can actually build. So age group is in between, the first class is somewhere in between 20 to 30, what is this, 40, around 40 45, right? And median value is 45, whereas for passenger survived 0 for passenger 2, median is 30, and for passenger 3 the survived, it is median is 25. Some analysis we can actually bring around. Okay, then again we have something violin plots where there is overlapping. So two violin plots are being overlapped to each other. So it says again what is the distribution of this data. So it looks like the probability density of these two values are being overlapping each other. So just hover over your mouse on this, so it says what is what, right? Yeah, so it says the p class for the age group, that is median value is 35, and whereas for this the median value is 28, for passenger third class median value is 22. Some analysis we can draw. So next we have something called strip plot, right? Yeah, so strip plot something looks like this. Okay, so again these are the different parameters. We have color, labels, orientation, ship mode, log x, log y, title, width. So again this strip plot is nothing but it is a something looks like this, right? So where we have a lot of categorical scatter points. So this each individual points we have, right? So each individual points are displayed on the single axis only, right? So again this is useful for visualizing the distribution of the dataset within the different categories. So yeah, so if we have 1 2 3 categories here, so we can actually have again survived and not survived in one class, survived not survived in two class, and survived not survived in three class. So it says like what is the data points that are displayed here, right? So most of the data points are lying here, right, been dotted, so which are very close to each other. So this dotted represents the points or data set that are lies between this particular values, right? Yeah, that's it. You can actually change it, and then we have something overlap. So if I want to overlap this all this, I can use strip mode equal to overlap. Just go ahead and learn the syntax. That's enough, and you can change the different columns that is needed for your analysis. Yeah, then we have something called heat map. So Again, if I want to find is there any correlation between the two features, and also likewise I can actually use this particular visuals, right? So again, this is a technique where we can have a lot of colors here, right? We can actually check, and a lot of customization can be possible in heat map. Okay, we can actually check, what is this. So to represent the matrix of data, right, to corresponding in each cell, we can actually check that as well, to customize the examples based on yeah, different sorts. So here we have two different columns, that is M part and P class. Based on that, I can actually change height, width and all, and just draw a heat map on top of that which says what is what, right? Yeah, that's it. Okay, so it's nothing but different color maps around. So we can actually give different sort of color, right? So we are like, we can actually declare something like C map, where it is, or some other color which we need, and like that we can actually display and customize this color maps and all. Okay, so next, yeah, using the same heat map, we can actually check the correlation. Okay, so correlation, Pearson coefficient, like that. So it says like what is the correlation. So basically this correlation is nothing but finding the relationship between two variables. Okay, so it says here age and P class, what is the correlation? That is negative correlation, right? See, here it is negative. So see here, passenger age and ID, that is a positive correlation, that is 0.03. That means age and passenger ID has some sort of correlation here. So some sort of analysis again we can actually build. Okay, so that's it about the correlation part using the heat map. Okay, next, yeah, next is something but the counter plot. Okay, so counter plot looks something very different from the original, right? So it says like, we use the density counter plot and all those. So you can actually check, what are the different parameters we initialize and what is the height, width and all. Yeah, so counter plot, again, it is a graphical representation. So here we can actually have represent using the three-dimensional data in two-dimensional space. Okay, so it displays the level curve. So when I can actually zoom it and zoom out, it says, it displays the level or curves in which. Okay, so it says like what is each curve and how many counts I need and all those. Okay, this is not much use, but definitely it can actually, we can actually analyze for displaying some level curve or something like that. Okay, again we can actually check with different uh, columns and different colors, and can actually play around. Okay, and do some analysis. Again, the density counter plot we have, so look something very different, and lot of analysis we can actually do. Okay, yeah, next, how I can visualize in complete data points in three-dimensional space. So just zoom in, zoom out. So that is also possible in Plotly, right? Yeah, so that's why Plotly, we could say it is very interactive. Just hover over a mouse here, it says the plots are different, right? Yeah, looks very good. So it says, see, when I'm hovering the mouse, it says, so what I'm doing, Plotly ka import px.scatter.3d, then train, the name of my data frame, then x and y columns and z columns. So here we have three different dimensions. That means I need three different columns, right? And color with respect to which column. So it looks very good, right? Yeah, just hover amount, it says each point P class fair A survived, right? So two categories, one is yellow for survived equal to 1 and blue for survived not survived. Yeah, so these are different things. Okay, so you can actually change around with this. Okay, add a lot of other parameters as well. Okay, I think it's understandable till now, right? Yeah, so in the next section we'll actually go ahead and see different sort of ML, how we can do ML techniques. So this is about the data analysis, just we learned using the Plotly, right? So Seaborn is one of the data visuals we can actually use for analysis. Then here we learned about Plotly. Okay, yeah, next we'll see it in upcoming next sections about machine learning techniques. Okay, thank you.